content over everything.
Demands, you have way less. And so you can really push the same rocket to go to Mars. You can push it to go to Venus. Venus would be so cool.
Wait a second. I actually have a question about that because I've been wondering about something. The Earth rotates, right? The Earth has an atmosphere, and the atmosphere rotates with the Earth. That's what originates the Coriolis effect. That's why, when I jump up, I don't end up on another spot because the Earth rotates. Because the atmosphere is also rotating. Exactly. It's with the Earth. It's all moving together.
If we stopped the atmosphere rotating right now, it would smack
the whole Earth. Yeah. It would wipe it clean.
What is it? It's something like 1,600 kilometers an hour
It would be
around the equator.
Would be a worldwide disaster.
And in London it's about. It's like gravitationally bound.
Yeah. Yeah. So
it's
how
big.
you're in a car. You're driving in a car, right? In a bus, for example, and you jump up in the bus.
There's a physical border that we can see, like
the car roof, right? Yeah, but there's a physical border on the gas as well. The gravity is pulling it down. It might be really light, but over kilometers it becomes quite heavy. Over many kilometers. But the Earth is rotating, and the Earth rotation is slower at the poles than it is at the thingy. And so that creates turbulences in the atmosphere.
That's what makes the Coriolis effect. The winds clash together and they make hurricanes and cyclones, and they make
big
Coriolis
jet streams that dictate the weather. It's so cool. And one more thing is the sunlight is heating the surface of the Earth, so it is but unevenly. The mountains, which are white and I think they reflect so much of it back. The oceans are dark and they reflect it more. I mean, they absorb it. They heat up more. That means the air around them is pushed up, and that adds
Yeah, I mean, the equator, on the equator, the sunlight goes more straight.
Exactly.
So that's why it's warmer in the equator and colder in the poles.
Yeah, and it's more at an angle, so there's less intensity.
Of course.
Very cool.
But look, man, I wanted to ask you something, seeing that you know about this. The moon doesn't have an atmosphere like the Earth atmosphere, right?
It has a very tiny atmosphere.
Yeah, exactly. But it does have some atmosphere, because otherwise, if you jumped on the moon, you would end up in another spot, if there was absolutely no atmosphere.
No.
So there needs to be at least some atmosphere.
No. It could be absolute vacuum, and you'll still be going onto it. Because look,
but it's also rotating, right?
Do this really slowly. You as a rocket ship, you're going to be coming in, and you're going to do it the other way actually. You're going to be coming in and landing like that.
Right.
So you're now sitting on it with it. Now you've got that momentum that you're going with when you sit down. And the only time it comes when you want to take it out is when you want to get off it fully. You have to take energy to go sideways. If you just jump up, you just go back down again. That reference frame is like this.
But look, man, my point is that
you don't need an atmosphere though to stop you from going sideways. Because if it did, then right now if you jump, then you'd feel like a wind that pushed you sideways.
No, that's why we have an atmosphere, and it's going with the rotation of the Earth, and that's why I don't feel like a wind pushing me back when I jump up. You know what I mean?
Yeah.
Because it's all going together.
Yeah.
Just like the example of the car when
then why do you need the atmosphere?
in the bus? Huh? You need an atmosphere. Well, because if you didn't have any atmosphere at all, there would be nothing going with the rotation of the moon.
You would be. That's what's key. You would be.
What do you mean?
Your body would be. So if you jump, you'll still be going with the rotation of it.
That's not it, man. Look,
maybe if you jump really far out,
if I jumped on the moon and there was no atmosphere on the moon, I don't know if that's even possible, if that's even physically possible for such a large object to not have an atmosphere.
I mean, it'll have something, right?
It might be possible. If it's a huge meteorite, maybe. I don't know. But anyway, if I jumped on the moon and there was no atmosphere on the moon, then I would be hit by by the space that was there, because the atmosphere is not rotating with the moon.
There is nothing in space.
Yeah, sure.
To hit you. There's no ether or something like that. Space doesn't hit you.
Yeah, okay.
It's a lack of things.
That was a poor choice of words. I wouldn't get hit with it, but seeing that there would be no atmosphere to go with it, I would probably end up in a different spot than where I was. You know what I mean? Because the moon keeps rotating, and seeing that there's no atmosphere, when I jump, I basically separate from the moon that's rotating, and I would not go with the atmosphere because there's no atmosphere. I would simply jump, and I would end up here because, for example, the moon is rotating this way.
Are you saying like jumping like this much right now, or are you jumping like a mile up?
Yeah,
waiting
of
like
course it would
10
be
minutes
more.
and then coming down.
I don't think I would jump a mile up even on the moon.
No, but but you use something to like get you up that high. Like it'll take 10 minutes rather than like this little jump. Because okay, let me say why. Because you can approximate it to moon and no moon, right? You standing here, the velocity of the ground going this way is like 10.
Sure.
1. It's 1. Okay. The velocity of you going this way is 1. You're the same. So you jump and you come back down. You're at 1 here as well. You don't stop or slow down. You're still going at 1, and you're still going that way.
But wait, if there were no atmosphere, I would.
Huh?
If there was no atmosphere, I don't know if it's again.
No.
I'm wondering if it's possible. I'm wondering if it's possible for a large, planet or a large.
He stopped the thing.
I know I'm recording on the camera. This camera.
Oh,
Yeah,
you're
yeah.
recording on the camera.
I don't know if it's
Dude, I was gonna
possible.
say something that was not for the camera, you know? Okay.
Yeah. You know, the moon is not a planet. It's I forgot the name of the
The moon, a satellite.
satellite. Exactly, it's a satellite. Exactly. I don't know if it's even possible for a satellite to not have an atmosphere of sorts, at least something.
Yeah,
because
I mean,
it
like,
rotates.
depends on the size of it. And
Yeah, I mean, it
its
rotates
history.
and,
but then you'd be saying
should
like an
have some-
asteroid should
some
have
atmosphere.
some atmosphere as well.
I
Like
heard
that's
that, I
small
heard.
enough. Like it's small enough that it has enough gravity. I mean, sorry, it's large enough that it has enough gravity that the dust, the dust is still like sort of, it doesn't have enough energy to escape. So it just sticks around a bit until if something hits it, then it escapes. But that's not really an atmosphere. It's not really
Yeah, I
gas.
mean,
that's
maybe it was a
bouncing.
silly thing to say. Maybe it was a silly example to give. That what if there's no atmosphere? Because there needs to be something resembling an atmosphere. You know, when there's such a large body
But
rotating.
I would say, I've said this and I've said this again, you don't need an atmosphere to stop you from moving sideways.
Okay. But
Because I gave him a few jabs.
Because
How
when
is
you
that?
jump, you're still going the same, an object in motion will stay in motion. Unless
Because of
a
inertia.
force, yeah, exactly.
inertia,
Unless
yeah.
a force acts upon it. There's no force acting upon you when you jump up.
right,
Yeah.
right. Yeah, that makes sense. Yeah, that makes sense.
What do you do?
Well, here I usually come to to speak to people, to do speeches, or maybe to have discussions with people.
This is
But
pretty
yeah,
cool actually. Like,
yeah, this is a nice place. You never been here before.
no, I go to uni in Bath, so like I come here sometimes because friends have graduated and like they're working here. And we had some friends over where we haven't seen in so long, and
Yeah, I think you're right about the whole deal. Because of inertia, that's what should happen. I mean, inside of a car, you don't have the car obviously doesn't have its own atmosphere.
Yeah.
But because of inertia, when you jump inside of a car, you end up in the same spot. You don't fly back or move forward because the whole car is moving.
Shall I tell you something interesting? If you got like a van and you got like a piece of string to hold like a helium balloon in it, and you were to accelerate forward, where would the balloon go?
So
Would
wait,
would the
say it again. You got a balloon full of helium, right? You got
Yeah.
a string
And it's a string holding it down to the ground,
to the ground. Okay.
to the ground of the van. The van.
Of the van. Okay,
you
so it's tied
accelerate,
to the van.
You stop your stop, and then you accelerate.
Yeah.
Where would the balloon go? Would
Well-
the balloon tilt forward, stay in the middle, or go to the back?
Well, it
Did
seems
you guys get what I said? Oh, okay.
they might have not heard it. Okay, so you got this is the van, right? You tie the helium balloon. It's over here. You start
this
moving
is
the
the-
van.
yeah,
This
we
is
go
the van. You
this
start
way.
moving the van this way, right? So I think the helium balloon would go like this because of the wind, because
No
the
wind,
air.
no wind. You just it's inside
No
the it's closed.
still,
the
because
windows
of
are
the air,
closed, or the-
there's air around, and because of the air, because the truck or the van is moving forward, the air would make the the balloon kind of bend to the side because of the speed, and also because of the air. Those things would make it bend behind the
I'm
van.
smiling because no,
That's not it.
no.
Okay, so what would
It will
happen?
lean forward
The helium balloon will lean forward.
because the helium balloon isn't like a usual object.
Yeah,
It's-
sure.
Most objects are heavier than air.
Yeah. Helium is
helium
lighter
balloon
than
is
air.
lighter
Yeah,
than
yeah.
air.
I know.
So when the car goes forward, all the heavy air goes to the back. It's pushed to the back. Just like how when you accelerate fast, your body goes to the back. The inertia of the gas gets pushed to the back, and the helium inertia is less. By its definition, it's lighter. So it gets lent to the forward because all the heavy air is pushing to the back, and it leans forward.
Yeah, but the balloon is a physical object. The balloon gets resistance from the air as the van drives forward.
Yeah, but the air
so
is,
logically
is
it should go
trapped
behind.
in the van.
Okay,
No, no,
I
you-
thought.
you don't
Okay,
have-
never
you don't
mind.
have-
I thought you would tie it up, but it was outside of the van.
No,
like,
no,
on
no.
top.
It's inside the van.
Okay, it's inside the van. Okay, so there's no air resistance, right?
No, yeah,
Right.
yeah. Oh,
Right, that's an
fuck,
interesting
duh.
experiment. I got it now. I got it
Yeah,
now. Yeah, so
Or
it's
like on a
inside
train,
of the
or
van.
like a
Yeah,
train or
got it. That's why you mentioned the floor of the van. Yeah,
Yeah,
that's why I
yeah.
mentioned inside.
Yeah,
I get
yeah.
it now. I get it now. Yeah, that's pretty interesting. I never thought about that before. So you're
because
saying
of
it's
the-
gonna lean forward the
Yeah,
way that the
it'll
van is
lean.
driving.
It will lean into because it's basically because the air instead is leaning to the back. Like if you had a van full of water and air, the going forward will push the water back, right? Because it's much heavier
Right.
than the air.
Yeah.
But the air is heavier than the helium,
Yeah, of course.
so that's why it gets flushed to the back, and the lighter stuff goes.
Man, I gotta research about that. That's very interesting, actually.
I'm glad I made you interested.
And I never
thi-
thought about that particular experiment before.
I think I'm gonna head. I need to catch a train
Yeah,
from Paddington. Which
Thanks,
way?
thanks a lot for the interesting experiment.
Dude,
I
it
will
was
definitely look
absolutely
it
my
up.
pleasure, actually. Like, I'm glad that you got interested in that bit. It's
You're looking for a station.
yeah. It's like. It's
So
just
we got Marble Arch right over here.
Yeah.
I'm not sure which line you need, but
No. I'm
Marble
cycling.
Arch is the. Oh, your side. Okay.
Of course, look at this. It's been
Yeah,
in shot the whole time.
okay, yeah, of course. I know you have I'm
Dude,
on-
I've been cycling from
Cycling.
Clapham.
right.
You know.
It's pretty far.
Yeah. So, but I think I'm pretty close now.
To Paddington?
To Paddington, yeah. I think
Well, I'm not
it's along
sure.
this way a bit more.
Not sure about that. Maybe. Do you have like a city map or something? No.
Dude,
You want me
this
to
is-
check it out for you?
Let me just show you guys my current phone. I would totally recommend it, and this is why I'm showing it to the camera. You reckon he's still recording?
Yeah, I think so.
Well, it's still recording. Look at it.
Well,
It's my banana phone. This is how I pick
Oh.
up my call. This is how I close the call. And it makes phone calls way more interesting and puts smiles on people's faces. And it's pretty
the
tough.
banana phone. Let me
The
see if I
banana
can catch.
Nice ring, dude.
Thanks, man. So you're looking for Paddington, right?
Oh my god. Yeah, I should be close.
Paddington. Okay, Paddington. I'll look for the station. You can get. I can look for
there it
buy food. You can cycle. Okay, yeah. So it's this way.
And then to the
Yeah, you
right.
get out of the park, basically, eventually.
Where is this?
We're here, right?
No. So it's not. So I keep going, get onto the main thing, and then the first right, and then I go up, and then I just go along this big road. Got it.
Yeah.
Thank you very much, boss.
Maybe ask somebody else over there so you don't get lost.
Easy,
'Cause it's,
dude. How do you
it's
think I got
confusing.
here?
Okay. Good luck. Man.
ContentCOE everything from your community.
Man, say it straight. Man, don't listen to BBC. Man, don't listen to ITV. Listen. COE. Man, don't listen to BBC. Man, don't listen
Like that,
to
yeah?
ITV. I don't even listen to
This is a bit much.
I just listen to COE.
Alright, cool.
Man, don't listen to BBC. Man, don't listen to ITV.
I've got to address a few points. Unfortunately, lately there's been a lot of claims made in online and those claims have to be addressed. The reason it has to be addressed is, you see, unfortunately we've got a lot of people who are claiming that, who are basically claiming that, you can't, okay, it looks like people, well, apparently people are saying that you can't criticize Islam. That's not the case. With some people, it may come across as like that, but that's not the case with me. You can criticize Islam as much as you want. I'm not insecure about Islam at all. What I don't like is that, what I don't like are blatant lies to be perpetuated. The reason I don't like blatant lies to be perpetuated, especially in this current climate that we're in,